Hi guys, so for the last lesson, we are gonna talk about slopes and coordinate planes. The overview of this lesson today, components. First, we're gonna talk about components of coordinate plane. What is coordinate planes? Second, we're gonna talk about graphing slope and points, calculating the slopes and gradients, real-world application, and of course, some practice problems. First, we're gonna take a look at the components of coordinate planes. The definition of a coordinate plane is a two-dimensional surface formed by two perpendicular lines called axes. The components of the coordinate planes include the x-axis, which is the horizontal line here, as we see here, and the y-axis, which is the vertical line with a line that is perpendicular to the horizontal line. So these two lines made up of the coordinate plane. And also don't forget to add the arrows because the coordinate planes goes on infinity. So it never stops. The origin is the 0, 0 point, which is basically at the 0. And then we have the gradients, which we'll talk about later, and we have the units on the both axes, x-axis and y-axis, to indicate that what unit it is on. Second, now let's take a look at the first real problem topic here today: plotting points on the coordinate plane. First, we're gonna identify the x-coordinate, which is the horizontal movement. Then we're gonna identify the y-coordinate, which is the vertical coordinate. Plot the point where the two coordinate meets. So what does that mean? First, we're gonna find the x-coordinate, which is the unit on the x-axis, which is the horizontal line. For example, this case, the first number in the order pair, we call this a order pair. Order pair. The first number will always be the x-coordinate. A will always be the x-coordinate, and B will always be the y-coordinate. So how do we apply this on this scene? First, we're gonna find the x-coordinate. In this case here, it is -5. So we're gonna take a look at the x-coordinate first because the first number represents the x-coordinates. So we're gonna take a look at the x-axis and find -5. So -5 is here. And then we're gonna take a look at 3, which is the y-coordinate, which is the second number on the order pair, and we're gonna find it. So this number here is 3. So we're gonna move up 3. Y equals to 3 means 3 up. And then we're gonna move up 3 to here, this point. So first we're gonna find x coordinates. And then we're gonna find the y coordinate and move up or down from that point to vertically. So for example, if this is -5, -3, we're gonna have -5 here. And then we're gonna, because this is -3, we're gonna move down 3 units. So 1, 2, 3. So this will be -5, -3. X and Y value tells us how far from the center, which is 0, 0 origin, a specific point is located. And X means right and Y means up, down. Okay, let's take a look at some examples here to help you understand better. Okay, let's take a look at number A here. So number A, let's take first number will always be the x coordinate. So we're gonna look at the x coordinate here. The x coordinate here is 4 because we move 4 to the right. So and on the coordinate it shows it's 4. So we're gonna write 4 as the first number, and we're gonna find the y coordinate. The y coordinate in this case is 4, 2, because we move 4 up, and we're gonna see the y coordinate units on this point here. So A will be 4, 4, B. Let's take a look at B. In this example here, this doesn't represent a whole number, so we're gonna find the fraction. This is basically just 3. So the x coordinate will be 3 because -3 actually, because it moves 3 to the left. And on the plane here, it represents -3. The first number always represents the x-axis. So this the order here can also be expressed as xy. This will be the y-axis. Y-axis, x-axis. -3, and then we're gonna see that the y-coordinate for this one is approximately 1. So we're gonna write the y-coordinate as 1. Alright, so that's for number B. Number C here. First, we're gonna find the x-coordinate here. So indicate on the x-axis, this will be 5 in this case. -5 because it moved 5 to the left. It's -5 here. The y-coordinate will be -1 because it moved down 1 unit, so it's -1. Let's take a look at D. D is interesting because it only moves down but not right or left. So when it only moves down, the x-coordinate, we also have an x-coordinate, and it will be 0 because it doesn't move anywhere. As indicated in the last slide, xy value tells us how far from the center 0, origin a specific point is located. In this case, the x-coordinate is on the origin, so we just write 0 there. And then the y-coordinate would be -1 because it moved 1 down. And on the coordinate here, it indicates that this is -1. Let's take a look at example E. In this example, we're gonna look at the x-coordinate first, which will be approximately 3 in this case. And so because it moves 3 to the right, we're gonna write +3 as indicated on the coordinate plane. And then we're gonna find the y-axis, which is approximately -5 because it moved 5 down again on the y-axis, and indicate as the -5 here. F. F is also quite interesting. First, we're gonna find the x-axis as usual. In this case, it will be 5 because it moved 5 to the right, and this is +5 indicate on the plane. It will be 5. And the y-axis, it hasn't moved up and down anywhere, so it will just be 0 because it's on the origin at y-axis. So pretty simple plotting points. You just identify the x and y axis and write them as ordered here. The first number is always the x coordinate. The second number is the y coordinate. Okay, let's take a look at understanding quadrants. The quadrant is basically how we separate or sort a coordinate plane into 4 parts. The first quadrant 1 will always be 2 positive, as this section here. Quadrant 2 will be negative. The x-coordinate will be negative and the y-coordinate will be positive. So it's this section here, quadrant 2. In this section, in the quadrant 3, both the x and y axis are negative, so it's only can be this one. Quadrant 4, only x axis is positive and y axis is negative, so it's gonna be this one at the corner right there. Practice problems. We're gonna find the what quadrant the shape is on. First, let's take a look at the triangle. So the triangle we can see here, both the x coordinate and the y coordinate is positive. So because you see here the x coordinate is 3, the y coordinate is 4. So when both quadrants, both y and x axis is positive, it will be in quadrant 1. Let's take a look at the yellow square. The yellow square you see here, the y coordinate is positive and the x coordinate is the negative. So this will only be quadrant 2. Let's take a look at the blue pentagon. So the blue pentagon, both x and y coordinates are negative, so this can only be quadrant 3 because that's the only case where both coordinates are negative. The green circle here. As we see in the green circle, only x coordinate is positive and y coordinate is negative. As you see here, x coordinate is 1 and y coordinate is -3. So this can only be quadrant 4. So you can memorize it like this way. 1 on the top right, 2 go left 1, 3 go down 1, and 4 go right 1. Okay, so quadrant pretty easy. It's just how we understand, sort and separate the coordinate plane into 4 parts. And that's pretty easy. Understanding slope. So this is where the complicated stuff comes. So slope is basically describe the steepness of a line. So we usually use the coordinate plane to indicate lines, and the slope just represent how steep the line is, or how far the line goes. The formula for the slope, this is pretty important here. Rise over run. So you just calculate the rise over run. What is rise? Rise is the point from one how does the y coordinate increase from one point to another point, and the run will be the horizontal change, which is the increase or the change of the x coordinate. So you can see here. Don't worry about this tan stuff. This will be trigonometry, which you will learn about in Algebra 2. So the formula will be y2 minus y1. You just grab 2 points on the coordinate planes and you calculate their y2 y coordinate, subtract their 2 y coordinates, the taller one to the smaller one, or the second to the first. And then you subtract the x coordinates on the bottom, which is the taller x coordinate to the shorter x coordinates. So that's basically how you get the slope. You just basically need 2 points and then plug this formula in, and you will get an accurate slope. Let's take a look at the first example. Calculating slopes. So first, we're gonna find the coordinates of these two points. The first one will be -3, -4, because it moves 3 to the, because the x coordinate here is at -3, and the y coordinate here is -4. So it will be the x coordinate on first, the y coordinate on second will be -3, -4, and then we're gonna find this one. In this one, the x coordinate will be 0 because that's on the origin x coordinate, and the y coordinate will be 2 because it's on the 2x axis. All right, so we find both of our points. Now we're gonna plug in the formula, which reminder is y2 minus y1 over x2 minus x1. In this case here, 0, 2 will be x2 x y2. -3, -4 will be x1 x y1. We're gonna plug in because we know this is x2 because this is the taller one. I usually see this as the taller one, so you can, or the one above is the x2, so we can basically do that. All right, so plug in the formula. Y2 in the first, y2 will be 2 here because as seen the second point, minus y1 will be -4. And then we're gonna subtract the x coordinates. The first one, x is 0. The second one, the x coordinate will be, the x1 coordinate will be -3. So subtract -3. We add them together. The first one, subtract, it cancels out, be a plus, become a plus 6/3, which is 2 here. Okay, so so the first complicated thing you will learn about this plane is calculating slopes, and then we're gonna Actually, we're gonna do another example here. We're gonna graph line using slopes. So this will also be our next topic or slide. Graphing lines using slopes. There's three main steps. Plot the first points. The first point, I usually like to see the first point as 0, 0, but in some example, it'll ask you to write the first point out, and then use the slope to find the next point, rise over run, and which is basically what we learned on the last formula. But in this case, rise over run. So you basically just do it will give you the rise over run, and you just do for example, in this case it will be -2, 1. So you move from point A down 2 because that's the rise, it's -2, so you move down, and then you move +1. Run is the horizontal move, so you move 1 to the right, +1. In this case, A is this one, so in this case you move 4 up because the rise is +4, and you move to left to the negative side, because the run is -2, and you draw a line. After finding the 2 points, you draw a line through them, and that will be your slope. Don't worry about the A or B points. It will give you it on the lesson we will teach you today. But in more advanced topics, you have to find the points yourself using the function. Let's take a look at graphing slopes. Graph a line with a slope of 1/2 with the starting point 1, 1. So we're gonna first, don't panic, we're gonna find the starting point first, which is 1, 1. And then we're gonna find the slope is given, it's 1/2. So the rise is 1. The run is 2. So we're gonna rise up 1 because it's positive. And then we're gonna run 2 to the right because it's +2. And go to the positive side, move towards the positive side. And then the next point will be 3, 2. And then we're gonna draw a line through it. Through these points. This and this will be our slope. It's pretty simple concept. You just plot in one point and you just run up and go. You just find the rise. You go up or down, and you run. And you run right or left. The denominator will always be the run. The rise will always be the numerator. Let's take a look at another example. Graph a point with the slope of 3, 4. With the starting point of 1, 3. So we're gonna find the starting points first. 1, the x-coordinate is 1, and the y-coordinate is 3. So it will be this point here. And then we're gonna find the rise, and rise will be 3 in this case because it's the numerator. Run will be 4 because it's the denominator. So we're gonna rise up 3 because it's positive. 1, 1, 1, 2, 3. It will be 6 in this case. And then we're gonna run 4 to the positive side, which is right because it has positive denominator. So we will go 1, 2, 3, 4, right about there. Then we're gonna connect these two lines. And there you go, we got our slope here. So pretty introductory topic in a graphing slope. This is probably the first thing you should know when coming up with slopes or coordinate planes, and eventually we'll know how to graph stuffs like parabola, which is a shape like that. But that will come in later high school classes. Okay, let's do this slide here. Identifying slope types. there are four main types. Positive slope. Line rises from left to right. So it rises which go up from left to right. And the negative slope line falls from left to right, which decrease from left to right. So the left point is higher than the right points, and in positive, the left point is lower than the right point. Zero slope horizontal line. So this will be a horizontal line and will be zero. No increasing or decreasing from both left to right. Undefined, which is simply a vertical line. Line does not move to the left or right. It's just undefined straight one. Why is this undefined? We will see in later example as I will show you next in the example here. So let's identify these slope types. Alright, first one. We can just simply see these 2 points. The left point is lower than the right point, so this will just be a positive. And in this case, the left point is higher than the right point. This will be negative because the slope is decreasing down. The positive is uprising. In the negative, it's decreasing. A horizontal line. This will be a zero slope. In this case, it's a vertical line, so this will be undefined. Why we say this is undefined? So mainly, in most example, we use slopes to referencing. For example, car speed. For example, when traveling. For example, when you travel 3 hours, you're gonna travel 30 kilometers. 3 kilometers, just a reference here. And you want one at x coordinate only reference to one y coordinate. So in this case, one x coordinate is reference to multiple y coordinate. So this will not make sense because you cannot drive 9 hours and drive like all the distances. So that's why a vertical line is undefined. Let's take a look at this example. This will be a positive slope because the slope is uprising. The left point is smaller than the right point, so it's uprising. The last example is negative slope. The slope is decreasing. You see the left point is higher than the right point. It's decreasing down towards the positive side, and the y coordinate is decreasing. So that's why it's a negative slope. Real world applications of coordinates and slopes. So we, as I just said, in the undefined slope, we use slopes in graphing data in science and economics, designing road and ramps, mapping location and navigation. So, and also car usage. So the graph on the left compares the gallons of the tank after it drives, calculate the slope, and explain why it means in this context. Okay, the slope. First, we're gonna find 2 random points to calculate the slope. In this case, it will be 75. The coordinate, the x-axis coordinate will be 75. And the y coordinate will be 12. And this will be our x2 coordinate, x1 coordinate, because this is the first one. When the slope is negative, in this case it's negative, the taller ones will be x1, x2, because it is the earlier ones. For example, 75 is earlier than 150, so the x1, y1 will be the x 75, 12, and then the next one will be 159. Okay, we're gonna plug in the slope formula here. Y2 minus y1 is x2 minus x1, which is the slope formula. I'm gonna plug in the 2 points we found. The y2 in this case will be 9. Subtract the y1 will be 12 over x2 150 subtract 75. In this case, it will be negative because it's decreasing its negative slope. It will be it has a negative slope because it's a negative slope. It will be negative 3 over 75, which is basically 1 over 25. That's our slope here, and I want to further say why the undefined slope is an undefined slope here. So this is a pretty good example here. Why undefined slope is a vertical line. So if we plug in a vertical line here, the x coordinate will be 100 and the y coordinate will be everything. You cannot drive at 100 miles and have every single gasoline tank. You can only reference one singular point. So a vertical line doesn't make sense. Why does a horizontal line make sense? Because in this case, at all mile driven, the gallons in tank will always be a singular. The y-axis will always be the same. In this case, it makes sense because you can drive at 50 miles and have 7 gallons of gas, and 150 miles and have 6 gallons of gas too. So that's why a vertical line makes sense. This is a zero slope, and the vertical line doesn't make sense because it has because one x coordinate reference multiple y coordinates. That's why a vertical line doesn't make sense. And when we're testing slopes in higher advanced math class, we basically cross the vertical line here and see if 2 points cross each other. In this case, it will doing a parabola. So we do a vertical line test to see if 2 points cross together, and that will not be in this case here, this is a simple function that will not equals a function because it has one x coordinate reference 2 y coordinates. The summary. So this is basically all the summary we do today, and remember, the most importantly, we have talked about the the slope formula, which is y2 minus y1 over x2 minus x1. This is very important. All right, let's take a look at the challenging problem. Here's a drawing on general line that intersects the y-axis at a 30 degrees angle. So we doesn't have any reference point here and no slope here. We only have a degree. The degree here represents this slope, this angle here. So what do we know? So what can we do to find the slope here? So 30 degrees. Remember, 30 degrees will just be 30 over 100. So you basically solve it there. So simplify, it will be 310. So the slope will just be 3 over 10. Pretty simple. So the slope will be 3 over 10. If you plug in some numbers, reference number here, it will turns out to be 3 over 10 here because number 30 degrees is 30 over 100. There's another challenging problem. So we're gonna find all of the slopes here. So ignore this one. This is just undefined. So we're gonna find these two ones. These two slopes. All right, let's take a look at the first one. We're gonna reference this as number 1. This is number 2. Okay, number 1, we have 2 points. Negative. The x1, x2 will be x1, y1 will be negative 6, negative 9, and y1, y2, x2, y2 will be 2, 7. So we plug in the formula, it will just become negative. It will be y2 minus y1 will be 7 minus negative 9 will be plus 9 over 2 minus negative 6 will be 2 plus 6. Yeah, this will be 16 over 8 will be 2. So number 1, the slope is 2. M equals to 2. M is just simply the slope. Number 2 here. Number 2, we're going to plug in 2 of this. This will be x2, y2 in this case. So we plug it in. Negative 3 minus negative 9 will be plus 9 over 2 minus negative 6 will be plus 6. 2 plus 6 will be 6 over 8. Simplify further, 3 over 4. The slope will be 3 over 4 in this case. So we see in this case, a positive slope will always have a positive slope number result, and a negative slope will always have a negative slope result. So pretty just a simple pattern we discover in the vertical line is always undefined. A horizontal line is always 0. Okay, let's keep going here. Alright, that's the end of this class today. So this will be our last lesson. So I want to say goodbye here and thank you guys for attending the 4 lessons here. Goodbye.